In this experiment, we shall determine the specific heat capacity of copper by cooling it down below room temperature. For this experiment, we require the following apparatus: an electronic scales to find masses, a thermometer, a variable resistor to choose a suitable current, and a power supply, some wires for the design of the circuit, an ammeter and a voltmeter, legging, a copper block which is in the refrigerator, a stopwatch, and finally a heater. The circuit shows that the ammeter is in series with the heater and the voltmeter is in parallel. First, we record the initial temperature of the room, which is 18 degrees Celsius. We then bring the copper block from the refrigerator, which is cooled down, so this is at a temperature lower than the room temperature. We insert the heater and the thermometer into the block. We wait for some time so that we will read the temperature of the block before we start the experiment. And the temperature starts to drop below the room temperature. We keep observing the temperature dropping down until we record the lowest temperature reached. The minimum temperature is set to be 10 degrees Celsius. So this means that the block is 8 degrees below room temperature, and we shall heat it up to 8 degrees above room temperature to 26 degrees Celsius. We do this in order to compensate the heat gained by the heat lost. We switch on the heater and start the time simultaneously. We will record the voltage and the current every 1 minute. We will continue to heat the copper block until it reaches a final temperature of 26 degrees Celsius. Due to the slow conduction of heat energy through the block, we shall switch off the electric heater some degrees below the 26 degrees Celsius. We must make sure that the temperature reached by the block is very close to 26 degrees Celsius. We switch off the heater and stop the time simultaneously. And keep observing the temperature rising until we finally record the highest temperature reached. The highest temperature reached in this process is 31 degrees Celsius. We now remove the copper block and find its mass using the electronic scales. We find the mass to be 1005 grams. We record all the data in a table, and using the equation Q equals mc delta theta, we find the specific heat capacity of copper with a percentage error of 16%. The sources of error will tend to make the specific heat capacity to be higher than the actual value.